दोस्तों हमारे चैनल को जरूर सब्सक्राइब करिएगा और बेल आइकन को दबाइए ताकि जब भी हम नए वीडियोस डालें आपको नोटिफिकेशन मिल जाए.
Well, as of now, Capgemini exam is approaching, so that's why somehow by managing the time, I made this data structure MCQ videos for all of you so that you can get an idea that what sort of questions will be asked in your Capgemini exam. To know more about this, make sure to watch the complete video. Also, do subscribe. Let's get started. So the first question that we do have is determine the worst case time complexity of inserting a node in a doubly linked list. Well, you can expect questions from the time complexity, and that is what very important. That is why I have tried to include questions that can be helpful for you, and I will try to continue some sort of videos like this for you with respect to Capgemini. Well, currently as of now, they are asking the worst case time complexity of inserting a node in a doubly linked list. So how does a doubly linked list look like? Something like this. So here you are having a next node and a previous node as well, right? So this is what doubly linked list. Okay, this is what doubly linked list. Well, here they are asking that what is the worst time complexity for inserting a node in a doubly linked list? Okay, so worst case you have to consider. So what can be the worst case when you have to insert something at the last? This is going to be a worst case, right? When you have to insert something, insert a node at the last. So you have to traverse through all the elements present in the list, present in the linked list, and that is going to be your worst case. So what is going to be the time complexity? It totally depends on the number of nodes that you are having. Suppose you are having n nodes in your linked list, then what is going to be the time complexity? It is going to be of order of n, right? See, we always use BIGO notation for representing the worst case, and worst case is the case that we consider a lot to get a proper idea that what can be the situation, what can be the time complexity, what can be the consumption of time and space in the worst case, right? So here the correct answer is going to be option C. Next question that we are having is determine the asymptotic time complexity to insert an element at the front of the linked list. Okay, so this is your linked list. Okay, and this is head pointer pointing to it. You must be knowing that a head pointer point to the first node, right? And this is your linked list. This is how it looks. Let me make. So basically, linked list consists of two elements. One is data field, one is data, and another one is pointer field. So pointer is basically pointing to the next node. It is storing the address of the next node, right? So one is data and another one is pointer. Well, as of now, they are asking the determine the asymptotic time complexity to insert an element at the front. Suppose you have to insert an element at the front node. So what you will do, first of all, you will create a node, right? And in that particular node, suppose you created this node. In that particular node, you will store, what you will do, you will store the address of that node to which head is pointing to, right? So you will store the address of that node to which head is pointing to like this. And you will store the value as well. Suppose you want to insert a node having value 23. Now what you will do? Now you will make head pointer to point this particular node. So this is how we inserted an element at the front of the linked list. So here we don't have to do any sort of traversal or something. So this is going to be taken. This is going to take the time of BIGO of n. The time complexity for this case to insert an element at the front of the linked list is going to be BIGO of n. Let's see the further questions. In case of any doubt, if you are facing any sort of problem in understanding any question, make sure to comment. I will definitely try to reply. Also, guys, I always try my best to give you the quality material as possible and to help you out in certain ways. But even I am involved in certain other activities except making the videos on the YouTube. So please try to understand and please try to support. Okay, so next question that we are having, consider the implementation of unsorted singly linked list. Consider it has its representation with a head pointer only. So this is our linked list look like. This is our linked list, let's suppose, right? And this is a head pointer pointing to the first node of the linked list. Now what is happening? You have to determine that which of the given operation can be implemented in BIGO of one time, that is constant time. Insertion at the front of the linked list, I just shown you that just using two statements, you can just insert an element at the front of the linked list, right? So this is going to take the time complexity for this one is going to be order of 1, that is BIGO of 1. Insertion at the end of the linked list, for inserting the element at the end, you have to go through, you have to traverse through all these nodes, right? All these nodes. And how long the traversal is going to be, it totally depends on the number of nodes that we are having. So for this time complexity, for sure is not big O of 1, it is big O of n, right? So this is not going to be the correct answer according to given situation, because here they are asking operations that can be implemented in order of one time. Next we have the deletion of the front node of the linked list. So for front node, it is also going to take order of one time, because we are already having head pointer that is pointing to the front node. So we can simply delete that node to which head is pointing to, and just the node next to that one we can simply make it as head, right? So this is also going to take time. The time complexity for this one is going to be order of 1. Now deletion of the last node of the linked list. So for deleting last node, first you have to traverse through all the nodes, you have to reach till the end, and then only you can delete that particular node, right? So for this one also the time complexity is not big O of 1 but big O of n, right? So the two operations, that is insertion at the front of the linked list and deletion of the front node of the linked list. So these two operations are going to take the time of big O of 1. What is the correct answer? Option B. Okay, this is the correct answer. Next question we have that in the worst case, the number of comparisons required to search a singly linked list of length n for a given element. So what can be the worst case? Just tell me what can be the worst case when the element that you are looking for, is present at the last. Okay, is present at the last in the given linked list. So that is going to be a worst case, because here you have to go through all the nodes and the last one is going to be the node that you are looking for, and maybe a case that this node or like this element that you are looking for is not even present in the linked list and you are going through all the elements. So what can be the worst case? N, or simply like big O of n. That is going to be a worst case, because here you have to do n number of comparisons to search for a particular element in the given linked list, right? Now what do you understand by stack underflow? So this is how a stack looks like, right? So in stack underflow means when you are trying to pop simply means to remove, to delete. When you are simply trying to pop an element from the stack that is empty. So if you are trying to remove, if you are trying to delete an element from an empty stack, so it leads to the situation, it leads to the stack underflow. So let us see which one is the correct option. Removing items from an empty stack, right? Removing items from an empty stack, that is going to be a correct answer. Here's our next question. Determine the time complexity of pop operation when the stack is implemented using an array. Okay, so how does the stack work? How does the stack work? Last in, first out. Suppose we first push 24, then 36, then 48, then 54, right? So now they're saying determine the time complexity of pop operation. So simply pop means what? The element that we have inserted in the last will be deleted first. So this can be done. This is going to take just constant time, because simply by doing pop, this element will be thrown out. That is 54 will be thrown out. So what is the correct answer for this one? Big O of 1. So that is going to be the time complexity of pop operation. Let's see the next question about postfix expression. So postfix means, what do you mean by postfix? That operator will come after the operands. That is, first operands will come, first operands, then operator. Right? Let us see how this expression is going to be solved. So we are having A into B plus C divided D. Okay. So first of all, here you have to understand the precedence rule. So multiplication and division both are having equal precedence, but as if to solving such kind of expression, you have to give the importance to the, suppose if the operators are having same precedence, then you have to give the precedence to the leftmost operator. So multiplication and division both are having same precedence. So first we will give importance to this multiplication operator. So what is going to happen? AB star. So this particular part is solved. Now we have to solve this one. So now multiplication will be given importance, as if multiplication is having higher precedence than that of addition. So CD and this division. Now we have to add this, right? So what is going to happen? AB into CD divide plus. Okay, so this is going to be a correct answer. So you can see this answer we are getting in the option B. So option B is going to be the correct answer. Let's see the next question now. So here, consider the following operation performed on a stack of size 5. So let us see what are the operations. And you have to determine that after the completion of all operations, what are the number of elements that will be presented on the stack. So first we are pushing 2. Okay, we pushed. Then we are popping it out, so it removed. Then we are pushing 3. Okay. Then we are pushing 4, right? Then we are popping. So which will be popped out? Which element? The topmost, that is at the top, right? So 4 is popped out. And then we are pushing 5. Okay. Then we are doing the popping operation. So 5 will be popped out. Again we are popping. So 3 will be popped out. Now we are pushing 6. Okay. So which element, how many number of elements are present in the stack now? All these has been popped out. Only one element that is pushed at the last, that is 6. So number of elements present in the stack are 1 only. So only one element is present in the stack after doing all these operations. Okay, I hope that that is clear. Let's see the next question. Determine the minimum number of stacks of size n required to implement a queue. So already I have one video regarding that how to implement a queue using a stack. So there are two possible methods for implementing a queue using a stack. That is, either you can make NQ operation costly. I already have one video. If you don't know how to do this, what is the algorithm, then make sure to watch that video. I have included the link for the video in the I button. So either you can do NQ operation costly, or other approach that you can use is DQ operation costly. I have discussed each and everything that it depends on the situation whether you have to implement this algorithm, that is NQ operation costly, and whether you have to implement this algorithm. So it totally depends on the frequency, that if in Q operations you are getting too much, then you should go with DQ operation costly, so that NQ operation can take less time. And if you are having lots of DQ operation to do, then you have to go with NQ operation costly. Well, to get the proper explanation, I would suggest to go with that video, to watch that particular video. So for implementing the NQ, we needed 2 stacks basically. I have told each and everything in that video. So what is going to be the correct answer? B. Okay, so we need 2 stacks to implement the queue. Okay, queue of size n. Let me write size n. Okay. Which data structure required for breadth first traversal on a graph? I have always told you, like, I understand that there always remains some sort of confusion, and even we do forget that even after revising the things and so. So just remember a technique that BQ. B means BFS, Q means Q, BQ. So for BFS thing, for implementing BFS algorithm, what do we use? Q is the data structure that we are going to use. Okay, so that is going to be our correct answer. Let's see the next question now. A sorting algorithm is called stable if takes big O of n log n times, maintains the relative order of occurrences of non-distinct elements, uses divide and conquer paradigm, takes big O of n space. So what is going to be the correct answer for this one? Option B, that is maintains the relative order of occurrence of non-distinct element. Okay, so if suppose we are having a algorithm sorting. Okay, so if we are having a list like this, 34, 12, 84, 12, 34. Okay, so after sorting, how this particular array or this list is going to look like: 12, 12, 34, 34, 84, right? After sorting, this is going to happen. So what is a stable sorting algorithm? What is a stable sorting algorithm? That suppose this 12 occur first, right? According to the relative order, if we will talk, then this 12 occur first and this occurred later. So in the actual operation, when we have completed the sorting, then also this 12 should occur first and then this one, right? So this is what stability. This is what stability. So if an sorting algorithm is maintaining the relative order of occurrences of non-distinct elements, here they have clearly mentioned non-distinct, means they are not distinct, they are duplicate or they are similar. You can see 12, 12, they are similar, right? So that is going to be the correct answer for this question, that is option B. Okay, this is it for this video. I have included these many questions only, and I'm sure that these questions will be helpful for you. The level is not going to be that difficult. Make sure to have proper understanding of each and every data structure, theoretical knowledge as well.